Hi everyone, I'm Tereza Nedelescu, and I will introduce you to Reactive Reports. The presentation will focus on the functionality and uses of this report generating framework. The agenda includes a description of this tool and its unique features, practical applications and strengths of the Reactive Reports framework, examples of Reactive Reports applications, a demo, and finally a conclusion. So, what is Reactive Reports? It is an open source, scalable framework developed in Scala. It generates PDF reports programmatically. Scala is compiled using the JVM, so the code for Reactive Reports can be written in any language that runs on the JVM. For example, Java, Scala, Kotlin, and Groovy. It was tested in Java and Scala. It has built-in support for Akka streaming. Both in Java and Scala, it can generate reports with or without Akka. Reactive Reports supports three types of input. These are data streams, database records, or a collection of Java or Scala objects. It uses Akka to handle data streams. Reactive Reports applications can have one or more inputs at the same time of any of these three types. The output is comprised of one or more PDF files which get generated at the same time. Reactive Reports has several unique features. Firstly, it provides the ability to generate one or several reports at once in parallel from the same input or from multiple inputs, which may come from mixed sources. In Java, users would create reports programmatically. In Scala, one would use a domain-specific language or a DSL to create reports. This DSL is simple to use and less verbose than Java. Examples of these uses can be found on the Reactive Reports GitHub page. Reports can have internal links to an XY location within the report or to an external website. It has the ability to add a bookmark at a specific position in a page. Then, at a later time, you can jump to that bookmark. With this, it allows the printing of multiple columns spanning multiple pages without additional computations. It provides the ability to wrap text blocks of different fonts with different attributes and different sizes. A table of contents with page numbers, while generated at the end of the report, can be placed at the beginning or end of the report. Users can jump and write text or graphics to any other page from the current page due to its unique architecture. Reactive Reports applications are very practical. The first and most important application would be in the financial industry, in particular for banks, insurance, and financial institutions. Quality assurance departments would greatly benefit from reports for test performance, especially when they run automatically on a continuous integration continuous delivery system such as Jenkins. Reactive Reports applications also work for big data and stream data such as Twitter feeds. I will show you an example of such a report. Reports for human resources such as tax and payroll reports would benefit a lot from this tool. Sales invoices are another practical application, as well as reports with data coming from Excel files, and the list can continue. Here is an example PDF report created using this tool. It has an external image as logo at the top and a pie chart generated by the pie chart function, which visually summarizes the data from the first table. Two more tables follow on the same page, here and here, with a nicely styled table header and titles left and right justified. This report is another example created with Reactive Reports, and it has a table at the top over here, followed by another table with records going from left to right, just like this. Then a third table is on the same page, having records showing from top to bottom, over here. Next, I will talk about the strengths of Reactive Reports. These are handling big data, flexibility, speed, graphics, the open source license, and grouping based on a Java or Scala function. In the next slides, I will talk about each of these in more detail. Reactive Reports can gracefully handle very large amounts of data. It is designed to conserve memory, and users will not get out of memory errors for large amounts of data. The limit for memory is the hard disk size, and it uses memory pagination. Another advantage with regards to big data is the use of Scala Z memoizing for speeding calculations. Thus, it generated a 20,000 page report with images in only 4 minutes. Next, I will talk about flexibility. One important benefit of Reactive Reports is the ability to automate the generation of reports from a shell script or tool. It provides maximum flexibility for automation. It is much more flexible when compared to reporting tools that run on GUI. Flexibility comes from the fact that Reactive Reports applications are jar files, and they can be run with a Java jar command. Because these reports are written programmatically, they can be enhanced with other code, such as artificial intelligence or NLP. That is, one can pass data through some machine learning algorithms, and then the result is turned into a report. Another benefit of Reactive Reports is that it can be run from any place where Scala runs, or in other words, from any place the JVM runs. Reactive Reports applications can therefore be run from Docker and Kubernetes containers. Data can be chained between different tools and ends as a report in Reactive Reports. For example, Jenkins output can be sent through the Jenkins API and be turned into objects, which will be used to generate a report. The internal memory management uses RocksDB. This can be changed to a different solution. Code changes for reports can be tracked in GitHub. When speaking about speed, the following two experiments illustrate the capabilities of this product. Using Reactive Reports, a report was created with name and address, having 10 million records or 232,559 pages in 124 seconds. In the second experiment, a report having 1 million records was generated in 14 seconds. Reactive Reports has the full control and responsibility over the PDF generation capability. Graphics can be built in using lines, circles, and gradients. These are created from PDF primitives. Virtually any graphics can be made from these primitives. The pie chart function now uses these primitives. Besides built-in graphics, it can also include external images, for example in JPEG format. Reactive Reports has built-in functions for creating bar charts and pie charts. It can use different fonts which get embedded in the PDF. Elements are placed on a page based on coordinates and pixels, or they go on a new line. Reactive Reports applications can create in-document or external links and a table of contents at the beginning or end of reports. It supports the French and Spanish character set for the basic font. Other special characters, such as Japanese, are not yet implemented. Reactive Reports is free to use and modify for both open source and commercial uses. The license is LGPL. It does not use other open source products that have commercial licenses. Another important feature is grouping based on a Java or Scala function. In most other report systems, grouping is done based on field values. In Reactive Reports, grouping can also be done on a generic function. This strength comes as a result of the development of reactive reports in Scala, which is a functional language. In Scala, one can pass functions as parameters. Additionally, groups can be nested. Next, I will show you 3 examples of using reactive reports. The first example is a mutual fund statement. As you can see in the diagram, the input comes in the form of database records from an HSQL DB database. These records go through the Reactive Reports application and they result in the PDF report as an output. In the first example, the mutual funds report, we initialize a connection to the database over here, and then we populate the database with data, as you can see in this file. And then we go in the second file and we run the report. The report was generated, as you can see. Let's take a look more closely. Here is the report output. It's the same one that I showed you earlier in the slides. Here is the pie chart, and here is the table. Now, the second page has a header and a footer. Over here, the header, and over here, the footer. And it is written using English text and French text with accents. As you can see, it displays the French accents pretty well. The second example is a financial report. This time, the input comes as Scala objects. It goes through a Reactive Reports application, and it results at the end in a PDF report. Let's take a look more closely at the code for this example. So as you can see, the first file defines the data that goes into the report. So the data is made of Scala objects. This file defines and populates the data. As before, the second file has code to generate the report. We will now generate the report. At a closer look, the report that was generated looks like this. It has a table of contents at the beginning. Clicking over here takes us to page 6. It's also a longer report. It has 206 pages. Now this page has a table at the top and the second table where the records go from left to right, the third table where the records go downwards, and they are all in the same page. And as you can see, they continue on the next page with no problems until we arrive at the next record. The third example is one of Twitter feeds. The input this time comes as a data streams. It goes through the Reactive Reports application and it generates into a PDF report. Let's take a look closer at the code for this Twitter example. So first of all, it uses an open source library to connect to Twitter. This one was created by Daniela Sfregola. And so this first example contains the Twitter credentials. The first page contains the Twitter credentials. The second page has the code for creating this Twitter example. This example uses Akka streams to handle the flow of data coming from Twitter. It uses a source, a sink, and a stream, and these are all elements of Akka. So a source is over here, a sink is over here, and a stream is over here. Let's run this. And this is the PDF file generated at the end from Twitter. In conclusion, Reactive Reports is an open source, scalable framework developed in Scala that generates PDF reports programmatically written in Java or Scala. It is designed to conserve memory, and users will not get out-of-memory errors for large amounts of data. Its main strengths are handling big data, flexibility, speed, and graphics. Practical Reactive Reports applications can be in the areas of financial reporting in the QA department, reports on stream data, reports for human resources, and sales invoices. Finally, I would like to thank you for listening to my presentation. Here is the GitHub repo for Reactive Reports. I hope you will like and use Reactive Reports in your development. For any questions or additional information, the contact email is csaltocorporation@gmail.com. Thanks again, everyone.